Alright, hi everyone. We're going to go through exercise 21C, which is finding the equation of the straight line. I'm going to start off with the learning intentions. So what we want to be able to do by the end of this exercise is find the equation of a line given both parameters, so as in both the gradient and the y-intercept. We want to be able to find the equation of a line given 2 points, find the equation of a line using a graph, and also to be able to sketch and find equations of horizontal and vertical lines. Hopefully you've done this stuff before, but if not, here is a quick recap on how to do it. So what I wanted to do very quickly on this slide was just to recap the general form of a linear equation, which we found to be y equals mx plus c, where m is our gradient or our slope and c is our y-intercept. So these are our two fundamental things that we need to be able to find an equation of a line. The y-intercept occurs when x is equal to 0, and the slope, the way we can find a slope is using the formula y2 minus y1 over x2 minus x1. If you know all of this, this exercise should be very, very easy for you. Okay, so moving on, looking at your textbook, your summary book, we're going to start with 21C, determining the equation of a straight line. So the first thing we want to be able to do is to determine the equation of a straight line from its graphs. So the method one is the intercept slope method. So as we just talked about, m is the gradient, c is the y-intercept, where we can actually use the values given on this graph to be able to substitute them into here. Now I can already see that they've given me my y-intercept, which is 0 and 3. So I can just sub that straight into my equation. I know that c is equal to 3. So I now know y equals mx plus 3. There are two ways that we can go about finding m. So the first way is to actually use these coordinates and find what the slope is going to be. So if I were to do that, if we do our y2 minus y1, first thing I want to do is label our coordinates. So this is x1, y1, x2, y2. So y2 minus y1 means I'll have 5 minus 3, and x2 minus x1 is 4 minus 0. So 5 minus 3 is 2, 4 minus 0 is 4. So that means my slope is 1/2. The other way to do it is to substitute in the other point, 4 and 5, into this equation and find and rearrange for m. So I'm just going to do it in the little space that I have here. I'll get rid of that y. So the coordinate I'm substituting in is 4 and 5. So that means when y is 5, x is 4. So all I have to do is rearrange. So take, 3 over. So 5 minus 3 is 2. And m times 4 is just 4m. M times 4 is just 4m. And then divide both sides by 4. M will equal to 1/2. So those are the two different ways that you can find your m, given that we already know what c is. So the next example is example 7. And this is finding an equation given 2 points. So we don't know what c is. We don't know what any other variable or value is over here. So what we have to do is just rely on our gradient intercept form. So what we have to do is rely on our gradient intercept form, mx plus c, to be able to find it. So what I can find from these two coordinates over here, given that neither of them are the y-intercept, is the gradient. So same thing, exactly the same as what we just did before, labeling your coordinates, x1, y1, x2, y2. Then we want to go y2 minus y1, so 10 minus 1 over x2 minus x1. 10 minus 1 is 9. Sorry, it's meant to be a equals. It's a very bad equals. And 4 minus 2 is 2. So that means m is equal to 9 over 2. So far I have, for my equation, 9 on 2x plus c. Now what I need to do is find c. The way I'm able to find c is by exactly the same way as what we did before with the second method, substituting in another coordinate. Doesn't matter which one in this case, neither of them will cancel x out. So I would suggest using the easiest one, and the easiest one that I can see is 2 and 1. So that means when y is 1, x is going to be equal to 2. So 2 over here cancels out with this over here, because that's 2 divided by 2, which is just 1. So we'll have 1 is equal to 9 plus c, and then take the 9 over to the other side to get c by itself. C will equal negative 8. So from there, I have my final equation, and I can write that down over here. Y is equal to 9 on 2x minus 8. Example 8 is just another scenario. So find the equation of a straight line with a gradient of negative 4 and it passes through this point. So this time it skipped this whole thing of having to find the gradient. It just straight away gives us the gradient. So I'm just going to do the exact same thing as I did before. Firstly, substitute in the gradient that we know. And now we need to find this point over here. And we can sub it in. There's one thing that I just noticed now. Can you tell what is special about this point? Well, it occurs when x is equal to 0, and what we know is that when x is equal to 0, that is our y-intercept. So we actually don't need to do the substitution. If you do substitution, you'll find you'll get the exact same answer. But I can tell that that is already c, so I can sub that straight into my equation. So that'll be y equals negative 4x minus 6. So it's really important to read your question very carefully and analyse what they've given you. I clearly just did not do that, so don't copy what I'm doing. Copy what I am saying, which is to read the question properly and recognise what points they've given you. Part B says find the equation of a straight line which passes through these 2 points. So I'm looking at these 2 points. There's nothing special about them. Neither of them are intercepts, which mean neither of them help us. So to find the equation, this is exactly the same as example 7. So what I'd like you to do now is to pause your video and to work this out yourself and to tell me what the equation of the straight line is going to be. Okay, so the first thing that we want to do to be able to find out what the equation is to work out our gradient. So exactly the same thing, x1, y1, x2, y2, and then we want to substitute them in, so y2 minus y1 over x2 minus x1. Now it's very important that this is negative, you put it in brackets, or that you recognise that it's two negatives together, because that's going to give me, so negative 2 minus 8 is negative 10. And this is going to be negative 6. Remember, two negatives make a positive, so that's negative 6 plus 4, which will be negative 2, and that will simplify down to positive 5, because two negatives make a positive. Subbing that back into our equation, 5x plus c. Now I want to find c, so use a point to substitute in. Neither of them look easy, so I'm just going to sub in negative 4 and 8. So here I can go 8 is equal to 5 times negative 4 plus c. 8 is equal to negative 20 plus c. Take the 20 over to the other side, that'll be 28. So your final equation, and I really do apologise for the messiness, your final equation is going to be 5x plus 28. Finally, for part C, find the equation of the straight line which is parallel to the line that and passes through this coordinate. Now, hopefully you remember in our first lesson we looked at parallel lines and what they mean and how we can find their equations. So the key word of parallel, actually I'm going to let you decide what the key word is. Again, I'd like you to pause the video and work out what the equation of the line is going to be. Okay, so the keyword parallel tells us that the gradients are the same. So this new line is going to have a gradient of negative 2. Remember that if it's not in the form of y equals negative 2x plus 3, you have to get it in this form, the y equals mx plus c form, to be able to truly tell what the gradient is. So in this case, we know that the gradient of the new line is going to be negative 2, and we also have one other coordinate that we can sub in. So I'll have y is equal to negative 2x plus c. Now I'm going to sub in this coordinate into my equation, so I'll have negative 10 is equal to negative 2 times negative 1 plus c. Negative 10 is equal to negative 2 times negative 1. Two negatives make a positive, so that's 2 plus c. Take the 2 over to the other side by subtracting it, so c will equal negative 12. So in the tiniest space that I have available here, I'm going to write out what the final equation is going to be, which is negative 2x minus 12. And this line, if you remember, parallel means there are two lines that look like that will never ever touch. Okay, so the final thing we're going to look at now are the special cases of horizontal and vertical lines. Now we've already touched on this as well in exercise 21a because we had looks at what the gradients of them are. So remembering that we've got two general equations, y is equal to a and x is equal to b. So y is equal to a is going to result in a horizontal line, which is going to have a 0 gradient, and x is equal to b is going to give us a vertical line, which is going to result in an undefined gradient. Okay, so let's have a look. So y is equal to negative 4. That indicates that we need to find the point at which y is equal to negative 4 and draw a straight line through it. Actually through the point, not like the one that I've done. It's as simple as that. So have a shot at drawing x is equal to 2. So all we want to do is find the point where x is equal to 2 and then just draw a straight line through that. And that's it. That's literally all you've got to do for these two types of equations, which are very straightforward and simple. Okay, example 10. Give the equation of the straight line which passes through the point 1 and 3 and which is parallel to the x-axis. So parallel to the x-axis looks like that, which tells us it's going to be a horizontal line. Now, as we just looked at before, horizontal line is in the form of y is equal to a. So that means it's going to be y is equal to a certain point that it goes through. We can tell that that y value is going to be 3 because it passes through that point there. The same idea, it's parallel to the y-axis, which means our line needs to be going vertically, which is what we looked at before. That is going to be in the form of x equals b, and just have a look at what the x value they gave us, so that is going to be x is equal to 1. Okay, so that is all of exercise 21C. It's pretty straightforward, but what you need to be able to do is just to practice it over and over to make sure that you fully understand how to sketch, how to find all of the different lines, given all the different scenarios that they may give you. So to finish this off, all I'm going to do is just quickly run through the learning intentions. So what we've done is we found the equation given a line. So the examples that we've run through today, we were given both m and c, and we were able to find the line by just substituting them in. We were able to find the equation given 2 points, so we found the gradient first and then subbed in a point to find c. We've looked at a graph and found the equation by pretty much doing the same thing, finding the gradient and then substituting in the c value. And we've also learned how to sketch and find the equation of horizontal and vertical lines. So again, if you're not sure about any of this, please rewatch the video or ask me next class. See you later.